Hello, welcome. In this workshop, I'm going to talk a bit about basics of Houdini for game jams. So I try to keep like a perspective of trying to keep things simple for game jams. So generating like simple constructions and showing you some of the basics that we can use Houdini in certain game engines, which you will see a bit more about, of course. I'm Simon Verstraete, and I will be showing you some of these elements to make things a bit more faster, or hopefully a bit more automated to make things better and faster. Now, what I want to talk about today is a quick overview here. So I'm going to start with the basic presentation. Then I want to talk about Houdini basics, just in case for people who are new. I'm going to keep this quite basic. Then once we have some of the basics, let's talk a bit about like simple workflows. Like how can we make something simple and export that into a game engine? To make things a bit more interesting, we can then go into like scattering assets, instancing, things like that, because it's very interesting to maybe have systems to instance and scatter around elements in a scene. Houdini Engine will also be very useful here as well, which if you don't know about Houdini Engine, I will talk a bit here in a moment about it. And to finish off our workshop here, I want to talk a bit about the Game Jam Toolkit, which is a toolkit for you available. You can already download this and try this out for yourself, which includes some basic Houdini tools, which you can break down, look into, modify. You can just try it as this, and so on. Well, if you have probably seen like previous presentations about Houdini, then you roughly know what Houdini is. So just quickly recapping some of the things is it's a 3D software package where we can do our modeling, animation, simulations, a variety of things. What makes Houdini a bit more special is it's a node-based system. So everything we do is going to be node-based, like you can see here on the screen. We make a box, we do an extrusion, we do a bevel on that. It's all going to be node-based. What is interesting with this setup is that this will make things a bit more procedurally. So that means that we can link values together. We can make an algorithm or a recipe that can define how an extrude node should behave or how a bevel node should bevel things. So we can do a lot of customization on these nodes. There is so much flexibility and control in some of these nodes that we can really make a decision on how something should happen in a network. So that's roughly what Houdini is, just node-based procedural setups. Houdini before has been quite popular in film with like its simulation options, but we want to of course use it in games, so let's talk about some examples as well. So in the game industry, there are a variety of usage. For example, large-scale scenes. As soon as we talk about open world scenes, Houdini is quite popular in this. Also optimization. Making a game requires optimization. So if this is again talking about like large-scale things, Houdini is also great for that. If you need to run over a couple thousands of assets and reduce them, make LODs, check the light maps or something like that, Houdini would be great to do that process all automatically and procedurally. VFX is also very useful here. Like I mentioned, Houdini is quite known in film for doing all kinds of complicated simulations. And we can now also bring that into a game. There are some nice ways to simplify effects and breaking them down into more real-time solutions. And finally, there's also in-engine tools. So this is what actually Houdini Engine is, which I'll talk about in a moment, where we can have Houdini inside of Unreal or Unity, for example. Now, so known examples here. Only going to pick a few. There are many more you can find. So here is Far Cry 5. If you have played Far Cry 5 or you're familiar with the series, they are often open world games. So they were interested in finding a way to make or generate open worlds. So they have a lot of forest scenes. So they generated that with Houdini. Like, for example, like why would I place every tree or bush or grass manually? There should be some form of tool that knows how to place certain models, so we don't have to manually do that. Another example here is Horizon Zero Dawn from Guerrilla Games. They made a tool here in this example for the water systems. So on the terrain, they want to maybe manually or automatically find a way to make these water flowing down from terrain. So they have a Houdini system that calculates the geometry for the water, but also like carves in the terrain to react to create a reaction from the water. Also, a lot of these examples I'm showing here are from talks and videos that you can find. So if you were to Google Far Cry 5 or Horizon Zero Dawn with Houdini, there's maybe more information there as well. Same for Spider-Man here. It's from a GDC talk. So Spider-Man is an open world game. So again, we need something that is capable of scaling things. So with Houdini, they were able to generate the buildings. There are probably a couple thousand buildings in the game. So how can we now do this more automatically? So Houdini was here a great way of doing that by instancing the modular props or kits that they had to make sure that they can cover a variety of buildings automatically, and also being able to iterate way faster if something needs to change. Now, a little bit about Houdini Engine. Like I said, we have options to have our Houdini tools inside of a game engine. So this is what Houdini Engine is. It's basically a plugin that you install for Unreal or Unity, and you can then open a Houdini file, which we will also use today. It's usually used for things like making geometry, setting instances, or making terrain, or even all at once. There are many more use cases of this, but those are like pretty common ones. So we can, for example, generate a terrain in Houdini. We can calculate where instancing of certain props are. And then we can also maybe generate new rocks or cliffs or something. And we can all make that in one single tool and send it to this plugin to Unreal or Unity to have it like fully scaled up into scene. Another example here is this quick level builder tool that I made a while ago. So based on boxes, you will define how your building shape would look like. So we're going to make basic boxes, define, for example, like a roofing space here. And in a moment, you will see that I will drag in my Houdini tool and I will assign those boxes to my tool so it knows where to place the assets. And I will then pick a wall or a roof piece and place it in the right position. So it just does that for you. Adding additional boxes could, for example, mean adding like a supporting beam structure, for example. So it leaves a lot of like openness and iteration speed for the user. By changing these boxes or shapes, we can change the building. If we want to make it bigger, smaller, we can now quickly do that. So since we talk about like Game Jam and Houdini, Houdini has been used in previous game jams. Side effects themselves have been sponsoring many game jams before, and Houdini was often used as well to make some of the games. So here are some examples as well. I think it is quite useful to know about. So here is from a game called Sir Steckums. So they were being able to generate platforms, for example, like they have a curve, they can draw the curve, and then they have a platform. You can do many things with this, like already like scatter some assets or other things, but it's very useful to now have a bit more faster iteration speed on like level design. If everything is based on a curve, you can just quickly draw different shapes and find out what the best shape is for your level. Another one is Picnic Panic. So it's sort of right in the word, like they have some picnic idea where they needed a lot of like different fruits and foods, which is also made in Houdini. As you can see here, one of the dragon fruits made with Houdini. And one more example that I wanted to show is Totally Unexpected Safety Drill, where they needed like some sort of like level building tool. So they quickly wanted to, again, like sketch out a level or a scene. So they have a tool for this in Houdini where they could plug in simple shapes and it will just make up the level for them. And then this will then be used in Unity to then make further their game. So they have like now very quickly iteration speed and also the ability to make many levels on a short time because they have a tool ready to go basically to generate something. And that's actually used in many cases here. So those were some game jam examples. There are many more. Just picked out a few ones that I've seen over the years, but there are definitely a couple more that could be interesting. So now with all that said, I want to jump into Houdini and talk a bit about how we can build some of these things as well. So when you first open Houdini, probably going to look something like this. So here we have our 2D viewport. We can also enable quickly the grid here. So here, if I just click on this, we will have our 3D viewport. Further down here, we have our node network. where we're gonna in a moment place nodes. So by just pressing the tab menu, we can then have the option to place nodes. The parameters of the nodes will be appearing above it in this parameter interface. Then this is like the most menus you will use, so the viewport and the nodes menus. And then above it, we have then the shelf tools, which are like pre-made options for you, but often we can also just hide it here on the side to get a bit more room. Same with the timeline. If you don't necessarily need the timeline, we can also just quickly hide it here as well. So we have a bit more room in a moment when we start to build different nodes and structures. Now, a couple other things to know about is here we have our basic tools here on the side. So different handles for rotation, moving. This is going to be our main handle, which is actually the important handle that I most of the time will probably use. This is the most important handle. And on the other side, we then have options here, for example, for lightning. You can also just here enable or disable the grid in case you want that. Then there is some additional information. If you want to see the points or the point numbers or primitive numbers, you can find this here as well, which is useful. I'm not going to talk about this too much, but it's interesting that you know if you want to see like the normals of a model or something like that, we can enable here the displaced normals, for example, if you want to double check the normal of a model and so on. Further, we can also here change the shading of a model. If you're interested in like having certain shading or matte caps, you can quickly adjust that as well. Now, in terms of then actually building something, we can here press in our object network or node network tab. And what is going to be important to understand with Houdini is the types of layers and networks we have. So if you want to make some geometry, of course, we want to go and here type in geometry. So this means that we're going to go in a geometry layer. So if I double click on this node, we will now here go to a geometry scene or layer. If I go back here to object, you can see that we are switching now back to an object layer. That's one of the first things understanding about Houdini is there are multiple layers and each layer has a different context. So a geometry layer has things like beveling, unwrapping, poly reducing. An object layer doesn't have these things because it's just a collection of your objects. So that's important to understand. For example, if I want to render something, we're going to make a ROP network, which stands for rendering operation. So here, this is a network, especially here for rendering and making outputs. So what we're going to mainly use today is the geometry layer. So it doesn't matter too much if you don't get this fully yet or are not interested in other networks. What we're mainly going to work with is, of course, geometry. We want to create geometry because I want to make a rock generator or I want to make something else, a tree, a house, setting instances, making terrain. These are all geometry things. These can be all done here in our geometry level. So to get started, for example, let's, for example, have a sphere. So tab, sphere, and here we're going to create our basic sphere. So in our viewport, we have our sphere as well. If you have that handle on here, you will see like also bounding box, which we can use to quickly scale and change the sphere if you want that. I'm just going to Control Z this, but we can also keep just the base shape. Then for each node, like I said, we will have then also parameters as well. So here we have the parameters for this node. So in this case of this sphere, maybe let's set this to polygon. So it's like a triangle sphere. So it's equally triangulated. And I want to do some, let's say like rock generation, some very rough rock generation. And we're going to change the frequency to, let's say 50. So we have a quite high density. And this will then be my base for example, for a rock generator. So once we have a base shape, how can we, for example, displace or move models around? So we can use something which is called a mountain node. And this will basically add a noise on the point. So here, if you plug in, you will see that by default, it will start to displace the model, as you can see. So we want to now go over here in the settings and play around with this. What is mainly interesting for us is here the noise value, which will basically control a bit the strength. So the amplitude here will control some of the strength. And the second part is then the pattern, the actual noising of the shape. So what are some interesting types of noise? So maybe let's increase our amplitude a bit and let's talk a bit about the noise types. So here we have a bunch of different noises. We can, for example, go here like again to Berlin noise, which is quite simple. But you can see like there is some additional noise on top of this. So if you know what a Berlin noise is, you will see that in this case, there's like some additional noising on this. This actually comes from here from the fractal tab. So here, this will actually add like an additional type of noise. So here for now, let's maybe disable this. And this looks more like a Berlin noise like we would expect. So we can always come back later and add an additional noise if you want to, depending on the style. If you want to go with something stylized, you probably don't want to have like a finer noise, right? So going here to another noise type, what is more interesting are, for example, whirling noises, Manhattan noise, or the other one. So here, let's take, for example, this one. Maybe let's lower the intensity, and you can see that this already looks really cool, like a sort of like rock or crystal shapes. So this works already really well. Let's try the other ones. So here again, this also feels some like a rock shape. So you have to sometimes play around with like the intensity to maybe get the feeling. But let's quickly go to some other noises. Here, some other great shapes you could use. Let's maybe go with some other shapes. So you can see quite interesting shapes and noises we have by default. So let's take the first one, Worley. I like this one. This gives a quite simplistic shape and look. And we can then here, as I said, like play around with this. Maybe don't push this too far. We can also here go with element size and offset. So the sizing will be sort of like the scaling of the noise. So if we put this lower, it will be more frequent. So usually like around 1 is actually pretty good. And also offsetting means that we just basically having a seed or variation or randomness in it. So every time I want a new one, I will basically change the offset, right? So here we have that shape. And what we could do with this is nothing is holding us back to maybe add an additional mountain, for example. So if we do an additional mountain on this, we will basically now add more noise on top of this. So again, we have to be careful with like our intensity that we give this. So it can be either very subtle, or again, it could be that we disable here the fracture, the fractal, and also maybe, for example, using something else. And you can see that sometimes this might not work fully yet together. So to make this better work, I would recommend going here and change this to positive, which means that it will the range output will always be positive value. So 0 centered means that it can also go negative, which means it will go inward, which can sometimes cause issues. So in this case, the positive works really well. And for now, we can also then easily change this. So we can add a subtle like second noising, as you can see, of that Worley shape. So in case you want that to maybe break up the shape a bit more, we can have something that like breaks it up even a bit more. So this is a base setup for a rock generator. Of course, this is not perfect. There is many things you can do here. But to keep going, another thing to make this in Game Engine is to probably do a poly reducing step. The only reason why you maybe can keep it on a higher poly count, maybe if you use Nanite for the game jam, then you can throw a couple higher poly counts at it. But we often just want to go and check our poly count here, and we're going to go with a poly reduction. So you can see it will just reduce poly count. So by default, it will often do like a decent job. So if this is like a sort of like smaller pebble or rock in the scene, this will be good. And also another interesting setting here as well is continuing to reduce without losing quality. If you enable this, it will reduce the rock by default based on a certain quality tolerance. So here I will reduce the rock to around 3000 primitives. If I don't do my extrusion, if I don't do my poly reducing nut, the default was 50,000. So we can see that by enabling this toggle, it will do an automatic reducing until it feels like it's enough to go to that tolerance value. But in case you want to like manually reduce it, feel free to like manually override this. We can also set this to output specific commands. Let's say, you know, your budget is 2000 or 1000. we can fill in that number and it will aim for that number to be as output. So that's like poly reducing, very useful now to quickly reduce elements. There are some nice features here as well to reduce your poly counts. Now, continuing with this, let's say I'm happy with my result, and we of course want to have some UVing. So we're going to keep it simple and using the auto UV. So this is from the side effects lab tools. So if you don't know what these are, if you're not familiar with this, I can recommend checking them out, of course. They're having a useful tool set available for free that you can use. So in this case, automatic unwrapping. So this is the default values. If we quickly go to our UV space, you can also change it over here. This is the default value, looks okay, but you can always like play around with other values in case you feel like other types might be better. So it's up to you on what you choose. Then we can go back. Then let's go back to our view here. So we have our V. Another thing we can of course do is setting normals. In case you don't have any normals here by default, might be good a reason to set it ourselves. So we can go with like the default of an angle of 60. You can go a bit lower depending on how you feel about this. Since it's a rock shape, we can probably go a bit lower. As you can see, we'll just make the rock shapes a bit more harder. So that can be nice if you would look this from like a bit more of a distance. You will be able to like recognize the rock faces a bit better. So from here, what you can do now is you can just use an FBX exporting node. So this is a simple like workflow. So here we can fill in a location where we want to save this. We can click on save to that location and it will be stored there. There is some additional settings here as well to if you want to export in this ASCII format. Sometimes you want to disable this and also as well converting units because there is a difference between Houdini, Unity, and Unreal. They have like different scaling units. So usually I would probably take this on. Otherwise, you might need to scale things up. So that's always good to know. And there are some other settings here as well. But what you may need to know is like here is the path. Then you click save to disk and you have a basic FBX exporting now. So this is a simple Houdini workflow overview, I would say. So we created a base mesh. We created a certain logic for creating shapes. In this case, I just mainly used noises to create a rock. Then we did some like optimizing and like default things you would do for games is of like adding UV, adding normal, and then you can use an FBX ROP exporter. So this is a basic setup to use. Nothing super fancy, but also like very useful. I can now quickly generate a couple of rocks in minutes just by going back to the noise, going here, for example, to the offset and changing the offset means that we will change different rock shapes. So in case you need like 20 different rocks, you can quickly now do that here by just playing around with the settings. Now going a bit into the next part that I also want to mention here is looking a bit closer at what exactly we have currently made. So we created a base shape, which is nothing too special. And then we used a mountain node, which is actually under the hood called an attribute noise. As you can see, it's called an attribute noise node. So what does this mean is that it will actually create a noise value and it will multiply this by the position. So here in our parameter, we can see that we are here using P. So P stands for the position of the points, and it will basically then multiply the noise by position, which of course will be a displacement. So we can also view the noise by clicking this icon here, which will, as you can see, like try to view the noise. So which in this case might not be the best as a visualizer, but let's maybe create like a new sphere. So we can create a new sphere, or if you want to have another shape, go ahead, like a box. Feel free to try other shapes. So we can have a new sphere. We can again set this to polygon and maybe increase the frequency a bit higher. So now I want to add a noise on this, but not on the position. I want to use this noise value to drive something else. So if we type in noise, we can of course grab our attribute noising here. And by default, it will be stored in something which is called a CD, which stands for color value. So this is the coloring, as you can see, of the colors of the points. So if you would enable or disable this toggle here, you might see or not see the colors. You might also here have the same icon here as well for visualizing some of these elements. So with this, it's going to be doing the same thing, like making certain noise patterns and storing this in the color of the points. Now, what we want to do with this is, let's say I want to have an extrude node that is controlled by this noise, by the noise. So attributes are really important to understand in Houdini. So we're going to create an attribute stored on the primitive, and then our extrude node will use that as distance for extruding. So a couple of things to do here before we can actually use this in the extrude node is, first of all, we need to set this value to a float, because an extrusion value is just a value of how far it will go. So here we can just call this noise. Can keep it simple, just call it noise. And like I said, an extrusion will probably be happening on the primitive level, so we can switch this to primitive. So now we have stored the float value noise under primitives. So for each primitive in my sphere, as you can see, it will generate like a random or a noise value. If you want to exactly see how these values are, I recommend going here to geometry spreadsheet. And here we have our options where to save data. So points, vertices, primitives, and detail. So usually like points and primitives are very commonly used, detail as well, but here we are mainly going to work with points and primitives. So here, as you can see, under primitives, we have a noise value that I basically here created. So if I would amplitude this, it will just create bigger values or smaller values. Now, this is basically ready to go. Another thing, if you want to visualize this even more, you can go here to the information icon, and then you can click on noise as well in case you need that. So in this case, it's displayed by a color. So that might be useful in case there is no icon here to press. You can always like view interesting data by here clicking on the values. So we are ready to go now. We have a primitive where a noise value is on. So let's now place an extrusion node. So on this extrusion node, we can then here grab the handle, or we can go here with distances. We can make a distance value. And to make this fully work, I'm going to divide the extrusion into individual elements, which means that each primitive will be extrude along its normal. Then we need to multiply the noise value with this distance. This can be done in local control. So with local control, we can use attributes to override values. So here, if I go and enable distancing scaling, by default it's filled in Z-scale, but Z-scale doesn't exist. So we want to override this and type in our own noise. And now, as you can see, we are now having our noise on top of this. So if I would create here some changes, you will see that we were now having different types of shapes. So this is a way on using attributes, for example, in an extrude node, which is really useful. So if you have like a game that's a bit more like sci-fi, this is quite useful to generate some of interesting shapes. This setup is also like, again, procedurally. So we want to plug in something differently. Go ahead, take, for example, like a big head, which is the classic test geometry. And you will see we'll just make something like this, where it will like randomly extrude those elements. Maybe quickly gonna hide here some of these elements, maybe hide the material. So we have our basic geometry now being extruded like that. So as you can see, Houdini is now quite flexible in doing these type of things. We can change things, can change the input, can change different nodes, can play around with noises, can play around with attributes. So these are the basic, essentially, workflows, I would say, is by taking a certain input shape, doing a certain logic on top of this, and then we have our result that we sometimes need to clean up to then export. So to reiterate as well, attributes are quite important to understand. So each geometry has attribute data. So in this case here as well, we can see that we have different types of attributes like position, different materials, different UV, different groups as well. So this is essentially to know about, if you want to understand Houdini better, this is going to be important that you understand what attributes are and how to use them. So there are a bunch of also like attributes nodes as well. If you just type in attribute, there are a bunch of attribute different nodes, but don't worry too much about that. As for example, the noising attributes and attribute the randomness is also very commonly used in many workflows. Now maybe let's go back here to our level here and maybe hide here. So for the next demo, let's make again new geometry network. And like I said before, like we're on an object level, so this is just a gathering of different object structures. So to keep things clean, you can just make new geometry nodes or containers to make something new. So here we want to talk a bit about instancing, scattering, and how this sort of like translates into the game engine. So let's start with the first step, which is like general scattering systems. How can I have a model and calculate points on the surface? So we're going to make the test geometry like a big head, which is the quite popular test geometry. And we want to then scatter assets on them. We also don't maybe need the shader for now. We're just going to scatter points on it. In case you are interested into loading your own files, because you might want to scatter something that you made in another program or that you maybe gathered from a library like Megascans, you can use the file node in that case. So the file node will point to the location of an FBX file and it will then load the geometry. So once we have a geometry, we can then use a scattering node. So there are mainly two nodes for scattering in Houdini on geometry. So we have the default scattering node and we have scatter and align. Now I'm actually going to use scatter and align because it has a couple nice features that I want to show here as well. So place it here and just plug it in like that. And it will usually spawn 1 point or a couple points depending on the scaling, of course. Now, the interesting setting over here is the coverage. So this is how much coverage, how often do we need points? Do we need this along the mesh or do we want to have this a bit less? So let's just crank this up to just 1. And then we only still have like 3 points, which is not that much. So we're going to also go with scaling, and changing the scaling means that we're going to spawn more points. Now, before I maybe add more points, maybe let's visualize them a bit better by adding something on top of them. So we can do here is grabbing something which is called a copy to points. Very popular node, very useful node. So we're going to copy an object, a geometry on a point. Now, our geometry can be something simple, just for previewing like a sphere. It could be a simple sphere. Maybe we can set this to a low poly sphere. And this is our input to copy. And this is then the points where we want to have the copy on. And this is then copying to those points. We probably want to set the sphere to scale 2 as well, since that will match the surface a bit better. So with our big head, I can now here display my big head. We have like a couple giant spheres, but let's add more of them. Like I mentioned, we actually need to change the scale to add more of them. So in this case, by default, the scaling will control how much points will be scattered. So we have minimum, maximum, and the uniform. So the uniform is like the global scaling value. So lowering this will create more points. Increasing this will try to create bigger objects, as you can see, bigger spheres. So we want to maybe lower this. Let's say be 2.2. So we have a bunch of these spheres now. And now to add scale variation, we can play around with min and max. So our minimum can be, for example, 0.5, 0.4, and our maximum could be like 2. So we have a nice variation in that. So now it fills the surface a bit better object. And like I said before, we can plug in different shapes, like I showed you in the previous example, plugging in something different. If you want to just maybe like preview it on a plane for now, that's also fine. Depending on, of course, what is the scattering we want to do, we might want to do different things. So scattering on the plane also usually means with this node that the intersection will also almost be none, since it does a good job at that to avoid intersection here. So this is like a useful scattering node. If we take a look at the other scattering node, if we plug it in over here, it will by default create a couple more points. We can plug this in like so. And what you will see is that by default, there is no scaling setup. It will all be the same scale value. So we need to actually do another pass of certain attribute changes to define what the scaling are. That's why the scatter and align node is really useful, because it does take care of scaling and also rotation. So if we quickly now go back to aligning here as well, the scatter and align, scrolling down will reveal also options for orientation and rotation. So we can now start to rotate this, but since this is a sphere, you won't notice the rotation, of course, too much. So maybe either change the object, or what if we just add a simple color? Let's bring up a color node, and we can give this like a random color or something like that. So now, if we would start to play around with the scaling, with the rotation, we can see that we can now randomly have rotations on these points, which is of course super useful. So let's say we are building a system to scatter foliage or rocks. We of course want every placement of a rock or some grass shape to be different. We want to have a slight rotation value in it, so it doesn't appear to be super repeating. So this is just useful that this is all built in the node, and I just recommend using this one for basic and quick scattering systems. Now, on top of this, what I additionally would usually do is also place another node, which is called instancing attributes. So it's called labs instancing attributes. So again, make sure labs is installed. I've used a couple labs tools, so make sure you install labs as well. So what this will do is it will sort of like take care of attributes for instancing, which is also directly related to Unreal and Unity. So in this case, there are options here to enable scattering for Unreal or for Unity. So you can enable these to make sure that they're working with that. So you can plug this in over here, and by default, as you can see, it should not change that much. It changed the orientation, and I know why this is, because if we go to point transformation, we have a tab here for rotation. The first one was for scale. So in rotation, it will try to look up existing rotation values based on the normal of the mesh. But the scattering won't put any normal. It will basically output something which is called an orient here. It does output a normal, but the orient has a priority. So we go here, I need to set this to orient. And now we basically have the same orientation, as you can see. Now, in addition on that, this node as well can do additional scaling and rotations. So here we can do additional scaling. We can also go with random scaling as well. So in case, like I said, if you would use the other scattering node, you would need to also, for example, here use this method to add additional scaling or rotation. So I can quickly go here and play around with some of the scaling and rotation values, as you can see. So this node is helping you in case you don't have any scaling, rotation values, things like that. So this is a very useful node if you would generate custom point clouds and you want to do additional steps to that, which is usually really great to have here. So I'm going to maybe reset my scaling values here quickly to the default. And maybe also I don't need the rotation for now, doesn't matter that much in my case. So that's our basic steps or our first steps. I'm going to delete this and we have our base system to work with. So I want to now bring this in Unreal. I want to have a tool that can scatter something on something. So I'm going to have an input, like a landscape or something that you made yourself. And then my tool is then looking at that object and then placing then certain rocks or shapes on those geometries. So the next steps would be making an HDA, so a digital asset. This is a very powerful concept in Houdini. So this is making your own custom tools and tool sets, which of course in long term, you will benefit so much from this, from having custom tools in your project. So let's wrap up this small system to something like an HDA. As my tool should have always an input, I'm only going to select these 5 nodes. So I don't need my sort of like input shape to be inside of my tool because I want to change my input. So we're going to select these nodes. We're going to go to assets. We want to make a new digital asset or new HDA from my selection. And it will then bring up a menu, and it will also here collapse, as you can see, the network. So we're going to give this a name like basic scattering tool or something. Basic scatter tool, and then we press OK. Then this menu will pop up, and this menu is mainly interested here in the parameters. This is for making a custom interface. So here, if we look into our network here, we collapsed our system into a node, and our parameter interface is empty. So this is why here we can create a custom parameters. So the way you can do this, there are many ways, is we can grab, for example, a float, can grab it in here, press apply, and now you have a float value with a slider. But right now it's not really linked to anything, so it doesn't do anything special. So I'm going to delete this, and I'm going to show you a bit of a better way of doing these things. So delete, I'm going to apply to make sure it's empty again. What we can do is we can go actually inside an HDA. So we can go back this in here, and we can start to modify our tool, of course, because this is the core logic of the tool. So what are important settings I would like to have? One of them is the scattering density. So going back to my scattering tool or scattering node, we're gonna go to our uniform scaling, and we want to basically now grab this value and drag it in our tool. So this is now our density. So I'm gonna just call this like density, or maybe just like density scale. And we press apply, and it will now basically turn into a green box. So green means that this has now been linked to or referenced to something else. If we click on the name itself, we can see the underlying logic, which has now a channel reference to something which is called uniform scale. So this is referencing now to my tool. So don't worry too much about this. It's mainly a very useful way to now link different things together here in Houdini. So the minimum and maximum radius is also very useful. So press apply. Something else that will be very useful in Unreal is talking about like the instancing and the objects we want to instance. So this won't necessarily work by default in Unreal. So we're going to go to our instancing tool that I've created here. And in there, we want to make sure to set it to work for Unreal. And I want to fully grab my instance variance naming here. And we're going to press apply. So our menu will now be expanded in a whole bigger area, as you can see. It will be now a bit bigger. So now, again, pressing apply and accept. And now let's bring this into Unreal and see what's happening. I'm definitely going to come back and make changes, but let's already see what's going to happen. So in Unreal, I have the default project. I just launched Unreal and I said like create a default project with no any content, which will give you this starter map. So before I want to use my Houdini tools inside of Unreal, same for Unity, is double checking that you have Houdini Engine. So make sure you have this installed, make sure you can use this, so you can start create session, and I will basically now start to link up with my Houdini. So this is the first major step if you want to have this connection between Houdini and Unreal or Unity, is to make sure that we have Houdini Engine installed. There are some videos out there. You can find tutorials on how to install this and how to get this. So go there and look at that. I'm not going to go here in detail about it. I'm just going to show you some of the tools directly in here. So I'm now going to open my content browser, going to go to my HDA folder, and I will now drag and drop my scattering tool. Oh, I will maybe dock this window, and I will drag and drop my scattering tool in here. So with my scattering tool here, we can of course drag it in the scene, and now it will start cooking. So it's now done cooking. It's ready to go, but of course it's just showing up the default Houdini logo. So we want to change this, and like I said, our tool needs an input. So we can see our parameters or the values that we made inside of Houdini. They are of course working, but nothing is showing up because again, our Houdini input over here, we need to say what input we should use. So to keep things simple for now is maybe let's make a sphere in the scene. So shape, let's add a sphere. Let's maybe make this a bit bigger, put it over here. And in our Houdini tool, like I said, inputs, we want to set this to something from the world. So here we want to change this to world outliner. So we want to pick something from the scene or the world. Now doing this will give us an option to select here and select sphere and use current selection. So the sphere is now being added to my tool. So you can see here that my sphere is now included as input. So I can of course add multiple objects. I can basically add this whole scene, but that might take a moment to calculate, as I will use the terrain of course for scattering, which I will show in a moment. So the default now is here that we have these spheres scattered on spheres. So this is my default result. So we can control the density. We can make this a bit bigger. We have then bigger spheres. We can make smaller spheres. So we can change and tweak the values. So what we should now also do with this is talk about instancing as well. So now I'm basically loading like an almost hard-coded object made inside of the tool, which is this sphere with this random colors that I made, which doesn't make much sense. So I already actually exported a couple of these rocks that I just made. I previously exported them. So you can do the same, like export a couple of these rocks that it just show you how to create. And we want to now use this instead of the spheres that we have. So going back to Houdini. So in here, if we go on our network, so we are creating our point clouds or our scattering points, and we directly are copying that sphere on top of this. So we don't want to do this step anymore. We basically want to directly feed a point cloud like this to Houdini, to Unreal. So for the time being, I'm just going to build a switch node. And I'm going to switch from one to another. I'm going to set it here manually. So I'm going to switch now to what the output for Unreal should be, which is just a point cloud with, the, of course, with the data that is needed. So what is usually needed when we send data from Houdini to Unreal is that, of course, we need an instancing attribute. So this node will take care for that for you. Then we also, of course, need information about how something is scaled and how something is rotated. So these are the important things to set. And this node will take care for most of it. That's why I like to use this node, because you don't have to go through additional steps. This node will make sure that it will work. So now this is ready to go. We are going to send a point cloud, saving our tool, of course, and let's go back to Unreal. Here we're going to our top of the menu, and we're going to click Rebuild. So Rebuild will make it from scratch, and what we will now see is these orange cubes. So that's already a good sign. That means that the instancing from Houdini to Unreal is working, but it doesn't know what to instance, because we still have not defined the component or the mesh to instance. So that's the first step there. Now, to do that is using this menu that I also made here, is using instant variants. So we want to give a path to what model to instance. Now, this is quite easily done. So we can take one of my rocks, drag and drop it in here, and it will fill in the path where this is in my game. So it's stored under game assets rocks. And then we'll scatter these rocks on the sphere, as you can see. And this is like an easy way of scattering these rocks now. So we can click adding more variants. So here we're going to click at additional, grab our other rock like this, and it will instance those rocks. So in this case, again, I'm using rocks as an example, but you can do other things like foliage, trees, buildings, whatever you have. This is just basically instancing and copying a model onto a point that we calculate in Houdini. Now, what if we can use one of the terrains here around the scene, which is, again, this is the default scene from Unreal. So let's take one of those tiles into our system. So under inputs, we can then change this to a landscape. So we can input a landscape. Now, there are probably a couple of these tiles, as you can see them. So I want to take something that has some detail like this. So this is one. This one is called 310. Let's go back to my Houdini tool. Oh, it's now hidden. So let's go here and set this to landscape, and let's find the 310 somewhere around here. Now, by default, I don't think it's going to scatter here. And the reason for that is if we go under advanced, there are many ways of sending your height field to Houdini. So by default, height field is just basically like a texture map defining the height of the terrain. But our scattering tool is not going to work with that. So we need to convert this into a mesh or export this as a mesh, which will, of course, our scattering tool will work with that. So here we are now scattering all these small rocks now on the terrain. And like I said before, we can go back to our sliders and play around with this, play around with the scaling. So that's pretty useful. We can change min maximum. We can also in here target the scaling of the objects themselves. So we can scale the rocks a bit bigger if you want to have like a really chunky rocky shapes. Now additionally, to come a bit more to an end here, is what if we now want to use the terrain information? Let's say I want to target something like a cliff maker or generating where things are different angled. So going now back to Houdini, in here we can change a couple things. So we have our pickup here as dust, so let's maybe increase the density scale, so maybe let's put it a bit lower. So we have the same idea here as, let's say we want to scatter objects where things are not flat. So before we are doing a scatter, maybe we can cut off parts of the geometry we don't want to scatter on. So we are going to use a node called split by normal. And this node will, like it said, it will split your geometry based on the normal it has. So this is by default now set to X, but we want to have the up axis, which is in Houdini the Y. So everything that is, for example, looking up will be selected here. So we can invert that. So everything that is not flat will be basically scattered by rocks. And this is then the tolerance of that. So our tolerance, this can also be parameter in the tool, but for now, let's maybe put it around like 15, 20, something like that, and plug it in over here. And let's go save our tool, and let's go back to Unreal. In Unreal, same as before, rebuild the tool, and we'll probably now, as you can see, fill up only parts that are not that flat, that are a bit more steep. So we can play around with this and have like I said, like a cliff sort of maker. Not exactly sure because we're actually instancing a lot of shapes. But this is a quite interesting setup now to play around with, to have like different shapes, different scales. It's nice to maybe have like one big rock and a couple one smaller ones. So this can be very fast if you need to dress up the scene or dress up a scene for a game jam, where this could be like a walkable area, but it's like flat. It won't place the rocks. Um, and you can have the parameter here to tweak that, but you can always go back to Houdini, of course. In Houdini, we can here play around with that threshold here. Maybe set it a bit finer, um, like this. Can boost the values a bit. Also, nothing is holding us back to do additional scattering and other setups. Like I can copy paste this node. I can maybe invert the node, and maybe now I can define where different grass models should be. Like here, maybe we have grass shapes, or maybe different tweaks or something like that, maybe different shape scatters. And we can do another setup where we have then another scatter system. We have a different scattering system. We can do another instancing system as well to instance different objects. And this can then be like, I don't know, maybe grass. And then we can merge this together like so. And then we have a generator for rocks and then one for grass, and maybe we can have another one or another one, another one, and so on. So we can now see that we can branch out and explore many different scattering options and systems. And you can go as advanced as also now starting to compare different systems. If you're be more familiar with Houdini, you can, for example, look into like Vex and Wrangle nodes. So here we can, for example, start to compare the different scatterings of each other, and we can write something interesting to maybe if we place a rock, maybe a rock has priority of placing foliage and so on. So we can do different things that react from one to another. That can be really interesting. But to keep things very basic, as you can see, with only these three nodes, basically, we can make an interesting scattering setup for you. So let's maybe switch, save this back again. Going to Unreal, rebuild the tool, and we will now have a bit more fine-tuned. So I put it a bit more extreme, as you can see. We don't have that many rocks, but it's quite interesting. Like it already gives a lot of interesting shapes. Instead of having nothing, it only like blends the shapes a bit better. Another interesting thing that I might want to mention is that this is also using nanite, in case you are interested in that. So my rocks are still a bit on like a higher poly count. They're not like reduced heavily, but nanite is doing like a great job to help us with that, of course. So we don't also have a lot of overdraw as well, since they are just rocks. So that's just great to know that we can just scatter or instance a nanite object, of course. This is not exclusively to only basic objects, but it can just scatter anything. We can also scatter blueprints, we can scatter light components. We can do many different things with scattering systems of Houdini Engine. So that was some basics of building a Houdini tool with Houdini Engine. So I hope you will have some idea now on making your own small little tool that does something like a scattering or making a rock or doing something else. There are many options you can do here. So just hope you can understand that this definitely will speed up your workflow instead of like manually placing rocks or having other ways of doing things more manually, but we can actually essentially do things a bit more automated by defining simple rule sets. Now, going quickly back to the slides, the last thing to talk about was the Game Jam toolkit. So I'm not going to show it here in depth too much. There is already a lot of information about this already. So this is essentially tools in Houdini that are available for free for you to try. So you can go to the SideFX website and you will be able to see starter kits for Unreal and Unity. So in this case, it's Unreal, but it's of course with Unity as well. Both have the same tool set. So you can open these tools, you can try them out, play around with them. There are all kinds of tools. I think there are like 10 to 12 different tools, from trees to edge damaging to level generators to rock generators, foliage. There's a bunch of tools for you to look into that can already be helpful in case you quickly need a tree or something like that. You can just load the tool, render out the tree, and make a new one, and so on. You can just quickly have trees, for example. There is also a lot of learning as well on this. So there's a learning page on how these tools work. So each tool is explained with a video. There is also more explanation in terms of just if you're new to Houdini Engine or this is the first time using Houdini Engine, there's a video about how Houdini Engine works and how you can install it. And then for each tool, there is a video, like I said, like for example, for a tree or for an edge damaging tool where you can input a shape, will damage the edges off. So each of the tools have video, so you can fully learn everything here in that page on sideeffects.com. And that was it for this workshop. So I hope you enjoyed it. I hope you learned a couple things here and there with Houdini. I hope you're interested in pushing Houdini and learning about it to use in future project or in this project already you're working on. And thank you.